so it's pretty cool. Let me get, let me bring this up, and I'm just gonna, all right, let me share this here for you guys. All right, how we doing? Everyone see?
Yep. Looks good.
Cool. Awesome. Yeah, so before I get going, just a little background. So I kind of mentioned, so Qumulo, kind of the basis of Qumulo and what this is. So about 8 years ago, our founders, they kind of came from Isilon. They've been in unstructured file for a long time. So our founders came from AWS and Isilon, and kind of post Dell acquisition, they had built the Isilon OneFS platform, and really were looking at the market, and really started to have a lot of conversations, especially this team came from AWS, built the S3 environment. They were some core engineers there, really looked at the market and said, all right, there are a tremendous amount of new unstructured file workloads, from video surveillance, from telemetry, from satellite rocket information, manufacturing, taking like QA imaging and doing AI workloads across manufacturing lines and looking for product defects and those sorts of pieces. Just a tremendous amount of growth of file data. And what they kind of did was look at that problem and say, all of the solutions today on the market, really, there's some fundamental challenges with the types of file being created now, whether it's small file or extremely large file. There's a tremendous change in the amount of performance requirement now that we're seeing, 8 GPUs driving API and needing tens of gigabyte a second of throughput performance. You've got, just a tremendous difference in file workloads than say 15 to 20 years ago, when a lot of the platforms such as Isilon and NetApp, ZFS, even Spectrum Scale from IBM GPFS, those were all built a long time ago for different type of workloads, and they're trying to evolve. But here at Qumulo, our founders came out of that space and said, what would we do differently if we wanted to build a new, modern, high scale, petabyte scale, billions and billions of files environment? What would we do? And so that's really what Qumulo is. We are in the unstructured file space, NFS, SMB, built for high scale. And our platform is software defined. So we, one of the key things is we built this software defined from the start. So we partner with HPE for our enterprise solutions. So we use HPE Apollo 4200 Gen 10, both all flash and hybrid systems. So I'll kind of talk through all this, but HPE is our go-to partner in the enterprise space for building these file platforms. I'm going to skip through a couple of these, but just to highlight, right, our goal is really to provide a new modern experience for building large unstructured file data environments, whether it's video surveillance, telemetry, manufacturing line, AI, enterprise file, document management, oil and gas seismic, all of that. So that's really what our focus is. And as I kind of mentioned, there, as we talk to our customers, as we did a lot of research building this platform, there's just a very large amount of data management nightmares and challenges in the scale and performance needs that we're starting to see and come across in all these environments. And that's really why we built and why we felt it was important to build a new modern file system. So we've been out for about 8 years. So we took a long time to build this file system to support high scale. This, we can scale to exabyte in size. We can, we're a node-based design. We, instead of building a file distribution type platform like Isilon has done with, distributing files across a scale out environment, we built an erasure coded backend block store that can support small and large files, that can scale node by node. We rebalance, auto scale, we did all that. And so the Qumulo platform is really built for scale. We can start 100 terabyte, 200 terabyte range, but we're really built, we are built for high scale, and we've got multiple tens of petabyte environments deployed right now in this space. Along with that is, giving customers the choice on really controlling the cost around that. We start with a 4-node configuration. Today, we're qualified to 100 nodes. That's going to jump up to 150 to 200 here soon, but we scale node by node. We built the backend erasure coded block store to be highly scalable. We add in a node, we dynamically rebalance. And so, we also have done some really cool things with using that backend block store to provide very high storage, usable storage capacity. We don't triple mirror files. We don't chew up space unnecessarily. We give you a lot of usable space because of that backend that we built. We have, as I mentioned, so this platform can run all NVMe nodes. So we can build all flash, all NVMe, drive some very, very high performance for commonly AI workloads is where we see that. But we also have the ability to build hybrid and archive nodes. So both, high performance down to cost-effective platforms. Our software solution can kind of scale to support that. When in a hybrid configuration, we've built a predictive cache and very intelligent kind of leveraging NVMe cache layer. So whether you're throwing, really high IOP random environments or doing a lot of high performance sequential, our file system and platform is built to kind of handle those workloads. Now, I would say one of the coolest things, having spent a lot of time in this space, is we give real-time visibility to the performance, the capacity usage, the trending, everything going on in the file system. I'll show you this. I think it's the best way to see it is actually to see, but all of the performance analytics, how users are using files, creations, deletes of files, all of that is, we pretty much built analytics and metrics as a real-time fundamental part of the metadata of our file system. So in real time, we provide visibility to what's going on and the growth and when you need to add nodes. And our customers really love it. I think it's one of the coolest things we do. And so we just built a really simple, easy to use platform to do this. In about 30 minutes, I can show you how to use and manage a Qumulo system and build a petabyte file system really, really scalable and easy. Any questions on that? Just to kind of give you a high level before I dive in.
Nope.
Cool. Yeah, and feel free to interrupt me. So throw me curveballs, anything you guys want. A little tougher in person. I could read the room a little better and kind of pick up on that. But yeah, just feel free to interrupt. So yeah, I mean, really at the at the kind of fundamental value prop of what Qumulo is we make it tremendously easy and simple to build high scale, high performance file systems for new modern workloads. Our UI is incredibly easy to use. I'll show you that and walk you through it. But you see there a screenshot of our real-time analytics on our dashboard. So right away we show usable capacity, real-time performance information about what's going on. And so we make it really easy to manage a high-scale file system, right? Like if you've worked with ZFS or NetApp ONTAP and those sorts of things, building out clusters on ONTAP, those things can be complex, both to install and manage long-term and scale. And we just make it really easy and take that away. We are a software-defined platform. Key thing there. So our enterprise solutions, we partner with HPE. We love their hardware for enterprise support. They provide us FIPS 140-2. Everything's encrypted by default in our software platform, but they give us an extra layer. We get encryption and security. Partnering with HPE, they are our go-to platform for the enterprise. Solid rock, solid hardware, great enterprise support. We're part of the Green Lake program for consumption pricing. And so, but this is a software-defined platform also, and what that really allows us to do is also deploy these file systems in the cloud. So we have on AWS and GCP and soon to be Azure. Actually, in a couple of weeks, we'll have our Azure solutions running. This same file system that you build on-prem with your HPE Apollo servers, you can deploy on the hyperscalers. It's the same software. It scales the same way. You use EC2 Compute or Azure Compute to create nodes, and we build a highly scalable file system. If you look at Azure, for example, Azure NetApp Files is a solution, or Azure Files solution up there. Limited scalability, 100 terabytes per file system. What we do is build petabyte files, scale file systems for the cloud. We're really the only ones that can do that at the performance level. EFS can build you big file systems, but 5K isn't really an enterprise solution on the AWS side. So we are a solution for high scale in AWS. The key thing there, it's the same software. So you build this file system with your HPE nodes on-prem, and you could build the same one in the cloud. Our replication, all the feature set, back and forth, gives you portability to really ingest, place data where you want to run analytics on it, and move forward. Same software, same real-time visibility, predictive caching, all that exists throughout all of the platforms. And then we are a modern API first design. So everything that's done in the UI is driven by API. We have full API, Python SDK, full audit log tracing that can all be done through API. We integrate with Tableau, Splunk, Elk stacks for monitoring. So a lot of automation and workflows can be built with our platforms. And that's what, especially a lot of the cloud customers will build workflows where data is like created on-prem, or they have a data lake on-prem. We have a cool feature called Shift, where we can replicate a data set to S3 natively on Amazon. Obviously, getting data in S3 allows you to do image recognition and a lot of the analytic workloads and other services on the platform. So we, customers have used our API to automate that portability of data, placing data in S3, running to image recognition or doing advanced analytics on it, and then dumping out the export, which you bring back on-prem. So all that is capable with Qumulo. Couple highlights of customers. We're in 5 of the Fortune 10 now. We have over an exabyte of capacity under management. We have over 200 billion files. One of the great ones up, I'm not sure exactly where you guys are located, but I'm up here in Seattle. University of Washington, the IHME is the lab that's doing a lot of the COVID-19 analytics and such right now, and publishing a lot of the metrics that decision makers are using. They have been running their analytical workloads on Qumulo for 5 years now, over 5 years. That environment is doing 40 gigabyte a second of sustained throughput. It is a very high analytic AI type workload that they're driving. We love watching it, seeing the metrics on it. They're actually doing that also with hybrid nodes. So those systems are not all NVMe, all flash nodes. We are capable of building all NVMe nodes, but a lot of customers, especially nonprofits, and cost-effective solutions are incredibly important. So we have, with our hybrid solutions, we use an intelligent layer of NVMe on the front end that's distributed across the nodes. 80% of workload activity happens in NVMe, and we've built some very smart predictive cache capability around that. And then long-term, the petabytes of data that you have that, where only maybe 10% of it is active at any one time, we retain on high capacity drives, 14s, 15s, 18s, et cetera. So that IMHE workload is doing 40 gigabyte a second of sustained sequential AI workload on a hybrid node, on hybrid nodes. So good kind of examples there. But San Diego Supercompute Center is using us for a lot of high-end HPC workloads. Hyundai is actually, so this is doing, self-driving car research and that whole space. Bosch in Germany is doing the same thing. So doing, AI work around building self-driving car and automation there. In, specific to the Boeing space, both ULA and Blue Origin are using our platforms for telemetry and QA and manufacturing. Every time, ULA does a launch or Blue Origin does a launch, all that telemetry is landing back. And really that's just due to scale. There's so much, all that data is file. It's a ton of file data coming in normal, these aren't object platforms. This is lots of file being created, and they just needed something that could scale with them as they ramp that up.
Shawn, so quick question. You mentioned NVMe, and maybe you're going to get to this, but are you guys utilizing any of the new Optane Intel data center persistent memory pieces within Qumulo? And I guess that kind of coincides with my next question of support. Do you guys support both the Intel and the AMD for nodes? And how does that work?
Yeah, yep, absolutely. So today we're using NVMe So we're using on the PCI bus NVMe devices for our NVMe. We also have some SSD, standard SAS SSD based platforms. We are not doing server class memory, so Optane or DIMM type activity. We're not doing that right now. That isn't something that we've built in. So we're using PCI NVMe today. Obviously, we're looking at it, but it isn't something we've built kind of in our space right now for what we're doing. Under the covers, the Qumulo platform is built on Ubuntu kernels. So under the covers, we're a Linux kernel down below, and so a lot of our support kind of that's where that happens. And then, sorry, could you repeat your second question so I can expand on that a little more?
Have you guys certified the nodes? So you mentioned Apollo, but are you guys utilizing the latest AMD chips for the storage nodes?
Yes, yes. So we are. We have both and AMD support. We do have some of our own white box nodes, just to show an example of how we can run on white box. And so yeah, under the covers, we're using modern Ubuntu Linux-based kernels as kind of our as our kernel operating platform, and we have both Intel and AMD support and nodes available for both.
Great.
Felix, I'll just add a little more color. When you're talking about running Qumulo on HPE, they're set configs, right? So
okay.
It's not build your own server, install Qumulo. It's which HPE Qumulo node cluster do you want to build, right? And there's like 6 right now that you can choose from, and they have basically set memory configs, drive configurations, processors, all of that kind of stuff that are built in, which makes it actually really simple, right, to deploy.
Right.
And the last ones that Jonathan and I, the last solution that we worked on, which we are pretty sure they're going to go forward with, was actually on DL325s. So they chose the AMD platform, the last one Jonathan and I worked on.
Perfect.
Yep. I think I got a overview in here, but yeah, we pretty much could do nodes, and then there's a number to the node, which is the capacity. So you just by capacity, so we make it really easy. But yeah, they're baked configurations and SKUs that we have with HPE, so that support. It's an HCL with support. So the kind of key, the Qumulo platform. So again, we're a software-defined platform, and what we call our file system and our data management platform is Qumulo Core. So Qumulo Core is a software-defined data management platform for unstructured file. It supports NFS, SMB, and FTP, so standard file protocols, for your Linux, Windows clients, and other machines that would write in those formats. And within Qumulo Core, there are kind of different features that describe what we do. For example, Qumulo Secure. All data at rest is encrypted with the AES-256. So we do software-based encryption on the HPE nodes. There's also the hardware-based secure encryption and the FIPS 140-2 validations. Those pieces are all there. So Qumulo Secured talks about our encryption. All data in flight, all replication, all data that exists in the cloud, we encrypt it all by default and at rest. So that's just kind of a standard feature. Everything with Qumulo, so you pretty much get everything, right? We're a subscription, through HPE. It's a subscription software product, and you get all the feature set. There's nothing else. It's a Qumulo subscription that it goes. We have snapshotting replication, so IP-based replication. It's a continuous replication technology. You can configure that at the directory level. So where you would configure your shares or exports, we do replication. Continuous blocked incremental change-based replication. That's Qumulo Protect. We also have standard snapshotting features. So we do kind of a similar B tree, as a modern snapshotting, B tree pointer-based snapshotting that you can configure policy around at the directory level. Has your normal .snapshot directory or integration with VSS on the Windows clients for recovery. So those are kind of your standard enterprise protection features exist within the platform. We have flash first design. That's our Qumulo Perform, our predictive cache capability. What we measure in the field is that 85% of our workload on our hybrid nodes is running out of the flash layer. So done some really good work around high performance. I mentioned, IHME is doing 40 gigabyte a second on hybrid nodes. Good performance there. Real-time analytics is our capability. So a lot of features that's really Qumulo core. So Qumulo core is the software that we deploy on the HPE nodes and scale up that way. It is a scale out node-based design. So we start with 4 nodes. You pick the node type by capacity, and we can intermix some of those together. It's a node-based design. We start with 4. Today, we're qualified to scale to 100 nodes, and that is going to be increasing this year, either 150 or 200. And that's just a qualification exercise. The platform can beyond that. So Qumulo core runs on, underneath. We have server queue, and server queue is the platform that runs on our HPE. And we do have some white box nodes, kind of legacy. We had to do that to kind of get to market and get some stuff going. We have our partnership with HPE, and moving forward, we are a software company. So we are getting out of the hardware business ourselves. We partner with HPE in the enterprise, and so server queue is our platform running on HPE hardware. We also have cloud queue. So cloud queue would be our software running on the hyperscalers. AWS and Google are rocking and rolling and good to go today, and Azure will be announced in 3 weeks. So a little preview there. We're embargoed by Microsoft right now on telling the full story, but I can tell you in 3 weeks we'll have that.
Shawn, so you mentioned, what was I going to ask? So you mentioned you're out of the hardware business, but so who does the qualifications for drivers and firmware and things that are, I mean, there still has to be some sort of, what type of drivers are you guys using within the actual Qumulo core OS that's on those systems? Like that's my ultimate question.
Yep, absolutely. So our hardware engineering team is not going away, and we actually grew that team a little bit last year. So what they are doing is managing a hardware compatibility list with our hardware OEM partners. What we do is actually recommend the, like we're using Micron, Western Digital, and other, and VME will recommend, hey, these are our preferred suppliers. These are the ones we qualified, and we will work. Our hardware engineering team works with, just like we've done with HPE. Here's our 6 SKUs. So we build BOMs with the OEM partner. We validate it. We build support around it. We publish and we build that support agreement with HPE. So HPE, will do level 1, level 2 support. We're there to back them all up. So that is our process. Our hardware engineering team's not going away.
Okay. And so just from a time scale, what's the normal, like when HPE releases their service pack for ProLiant, twice a year, annually, how fast do you guys qualify that to be on the Qumulo nodes?
Yeah, I can't directly answer that question. That's something I'm gonna have to follow up on. But what I've seen is twice a year we are releasing new nodes at this point, and new SKUs and new nodes. Jonathan, would you be able to add any color to that one?
Yeah, if I unmute. I guess it depends a little bit. My experience over the last 2 years, Felix, on that is that it's usually about a 6-month delay is
okay.
Pretty much what I've seen from when something significantly new comes out. It kind of depends though. I mean, sometimes if it's just a matter of like an HPA driver or something like that, sometimes those are qualified very, very quickly.
Right.
Yeah.
Okay. Right.
But yeah, I'm seeing SKU updates probably about every 6 months. And that's really what that turns into, right? Because you generally patch the entire system as a whole, as opposed to individual components, right? You're updating the Qumulo software. Yep.
Okay. That's okay. Yeah. I guess maybe there might be a slide on that later or something.
Yeah.
Talks a little bit about that.
Well, what I could talk to is our software development lifecycle. So, we're a modern agile shop. We actually release code every 2 weeks. Customers aren't required to do all that. We do automated non-disruptive upgrades. You go in, you drop the new code, and we upgrade the cluster non-disruptive. We release new code every 2 weeks, so we're very quick on adding in if there's a new driver that's needed. We have our SKUs. We generally will update our SKUs and our hardware with HPE every 6 months or so. But if there's new drivers we need to add or those pieces, those are coming out pretty rapidly. So our software development life cycle is pretty quick. And then what we do is releasing code pretty frequently, adding a new feature set every quarter. We have a roll up. And our enterprise customers tend to like that model because, you kind of bake a config, you want to run it a little while, you don't want to be, changing things every 2 weeks. So, yeah. All right. Some workloads here. I want to speed up because I actually want to show you guys a demo. So what we find, these are the typical loads. So a lot of connected autonomous vehicle, kind of a lot of that workload. These are all your new modern file workloads that you're starting to see. We do a lot in genome sequencing. We're doing a lot with COVID analytics right now. A lot of research based things. The aerial imaging satellite, Utah State actually is a partner with NASA around doing some satellite analysis, some stuff with Jupiter, all of that. They have, they actually just add another 5 petabytes. It's multiple tens of petabyte environment there where they're doing aerial and satellite data. Those are the common use cases. We're huge in media entertainment, corporate marketing. So there's a very large company that is a fruit company that, all their corporate marketing, awesome video creation that they do all runs on the Qumulo platform. And it's just scale of doing 8K and 16K video. Now that's a lot of data that's being created. So the other one I would mention is video surveillance. So we're partnered with both Milestone and Genetec. We have reference architectures with both around video surveillance. It's outside of M&E, it's probably one of our largest use cases. Those are easily 4 to 10 petabyte environments now with the using 4K videos and retaining that for a long time. I talked about this, but just to highlight, so Qumulo Scale, we're a node-based scale-out design. We've built, I think the key thing here, many people will say, hey, this, you kind of look like Isilon, right? What we did on the back end is we built in modern erasure coded. So if you think of S3 using erasure coding to build a highly scalable object store, we took some of that fundamental capability and did it for file. So we provide the scale of an object store and the resiliency and protection of an object store for file, both on-prem and in the cloud. So you add a node, we dynamically rebalance. We never impact user workload. That's all prioritized properly. But we automatically rebalance. It's really simple. You plug in a new node, we discover that node, you add it in. It's a couple clicks and away you go. Make it really easy to do that. I think a big differentiator that you will find is small file support. So most of the platforms that do high scale out file design really struggle with small files. Anything under 128K tends to get triple mirrored, and all of a sudden that petabyte you bought is 300 usable. So we do not have that challenge. We use a 4K block, and so we support small files very, very well. On the flip side, large files, totally fine. We segment that file up, distribute it across our cluster. Doesn't impact any restriping, rebalancing, and when you have a node offline or any of that, no impacts at all. So some nice competitive advantages that we have over the others in this space. Perform is our ability to do predictive cache. We also have all NVMe nodes. So our performance, we are built to handle AI and new modern high performance workloads. We have single clusters running in the million IOP, doing hundreds of gigabytes a second. That really depends on how much hardware you want to throw behind it, but our platform and our file system will scale to those high performance. Or you can start small, 4 nodes, 100 terabytes, and then you don't know how big this file system, some new AI workload or satellite workload comes in. I think that's a real advantage of Qumulo. Start small and just pop in new nodes as you need to. I'm actually going to jump in, I think, to the demo, see if there's anything else here. 40, and 100. The new Apollo 10s support the 25 up and 100 with Ethernet, but we are an Ethernet platform. And then just to kind of give you a highlight, these are the currently, as Jonathan mentioned, these are the currently built SKUs that we have on our HPE nodes. So you'll notice here on the platform, these are the HPE, and this 30, these numbers here just define the raw capacity of the node. And so, we start with 4 of the node. You can intermix some, the nodes together that are kind of close and near to each other. So for example, as we release new nodes with new CPU memory that, like the 192 will be refreshed at some point in the next 18 months, right? They can intermix with, if you've built out a 192 cluster, we can intermix those together. Our block store intelligently distributes across it. So we allowed mixed node support. Tend to see, so these 336, right, are more deep capacity. They're using, 14 terabyte drives. So these are going to be more for archive. They're not, they're going to give you really good performance, but, they're not getting, these things aren't built to do 100 gigabyte a second, unless you wanted to do a fair amount of nodes. And I have a calculator size that allow work with Jonathan on that piece. But so we have lots of different nodes that we have. Okay. Any questions there before I jump into, oh, I don't even need to stop sharing. Jump into our running system.
Do you guys have for the analytics, so that's all internal, or does that have to phone home and then you create an account and log in? How does that, I don't know, or maybe you mentioned that and I didn't catch it.
Yeah, no problem. So we have both. So I'll walk you through here. You see the dashboard here. Right. This is the cluster itself has all the real-time analytics right there that runs on the cluster. We do have the phone home and the kind of long-term trending analytic history, our mission queue platforms. So phones home, you get, dashboards and trending and long-term history. That also does our proactive support. Every customer with Qumulo gets their own Slack channel with our support organization. It's pretty unique and pretty cool, especially having spent myself a long time with NetApp and managing support experiences there. We close about 93% of our tickets actually in Slack with our customers. So it's a pretty cool way. But yeah, all that stuff, phone homes. But we are fully supported in dark sites. We have a lot of Fed customers that are dark. And so you can run this in a dark site. You don't have to phone home, and you still get everything I'm going to show you here on cluster real-time analytics is all there. Yeah, so this is, so you'll notice here I'm logged in with 80. I have administrator rights. Well, I have rights to kind of play around, but I'm not supposed to change things. So I'm logged in here with 80 onto this. This is, so this system is one of our internal software engineering systems. This is on-prem for us in Seattle. We have a data center up here in Seattle. This system, as you can see here, is a 10 node cluster. These are our older nodes. These are some of our original white box nodes. We do not sell these nodes, but this is internal, right? So we're eating our own dog food here. And so this is a live running system that I have where I can kind of show you. I like to use this one because I've got some real performance going on this one, and I can kind of show you what they're doing here. So when you first log in, this is our dashboard. We make it really obvious, what's the capacity, what's being used on the cluster itself. You see here, this is a 10 node. If we had a node offline or a drive offline, it would be taking activity, and you'd see that kind of highlighted here. By default, we support, two drive. We start with 2 drive and 1 node resiliency. So you can lose a node or 2 drives, everything's kind of fine, but you can increase that. So that's kind of our standard. Generally, if we're talking 10 nodes, I'm gonna increase the drive resiliency so I can support more drive failures. So that is something that we can configure to be higher depending on how much resiliency that you want. But that's kind of our default configuration. If I click here on the cluster, you'll see, so I've got 10 nodes here. This cluster is configured with 2 drive or 1 node failure. So it's protected with that resiliency. And that under the covers defines what our erasure coding policy is going to be. But we can increase that if you wanted higher resiliency. And we do when we get into higher node counts. But this is kind of a basic 10 node that we have. These are our old QC 24 nodes. So each one of these is 24 raw. We don't sell these anymore. These are older platforms. And you can see here, so this system has 143 of total usable. And you can see I'm using 130 terabytes on this right now. One thing to highlight while I jump back over here, we have designed our file system and our block store to run at full performance all the way up to 99.999%. So as long as you don't fill the file system up, we, as you probably used to in the storage environment, 80, 85%, you probably start to see some latency impacts as you start to fill a file system higher than that. We purposely designed our file system to run at max performance with no latency impact until it's full. So it's kind of a nice, it's nice if you buy a petabyte from Qumulo. So I only talk usable capacity from a sizing standpoint. If you want a petabyte, I'm going to design you a petabyte usable, and you're going to be able to use that full petabyte, irregardless of whether you're putting small or large files. And you don't have to worry about keeping it at 80% or 85%. This cluster, we're commonly bumping it to 98 or so. Right now we're at 91, but it's kind of a nice feature. So you get to use the space that you've invested in. Give some good information here on just, the files and directory count that you have and kind of what that activity is looking like in real time. And then what I really like to dive into is this real-time performance. So on the cluster right here, you've got 24 hours of real-time performance. You can kind of slide this around and see, you get that ticket that says, hey, storage was the bottleneck at 3 a.m. Pop in here, kind of narrow it down, start to look, and all right. So at this time, you told me you had storage was the bottleneck, and the server network team's pointing at you. Well, I can look right here and see, well, at this time, my latency was 0.1 millisecond of read and 0.7 of write. I don't think I had a storage problem. So it allows you to answer those questions really quickly. Or you can watch it in real time and bring that slider out here and see what's going on in real time. So my old nodes here are having some write latency going on, but you can see what's going on in real time. The other nice thing for network troubleshooting is we break down the sequential distribution. So here you can see that, this system is running under 20 megabyte a second of read and under 40 megabyte a second of write most of the time. 10 gig network, if you're hitting 600, 800 megabyte a second, you might be looking at network saturation, and the network team, you may want to, storage, you'll start to see your latency uptick at that point. So we give you a view here over the last 24 hours if you've started to bump into any network congestion at all. And you can see that. So this is just more, make storage admins' lives easier to understand what's going on the storage platform. We have full client analytics, so I can show you some more into this, but we break down which clients are your most active, who's using the most space. Awesome for home directory use cases to see that, John is maybe chewing up a bunch of space and what's he doing, with that. So I can, expose that. And then some other cool things here of, all of a sudden a bunch of space just got chewed up on my cluster. That's a hard problem to answer in like the NetApp world or others, right? Or if you had a big ZFS environment, really quickly, hey, something, they just added 2 terabytes in build. Now I know where to go look and see where that's at. And then we kind of give you some trending over the last 72 here. So we are node-based design, so we just give you visibility into the distribution of clients across that, so you can see if you get any hot network load going on. Capacity trends, this is really one of my favorite ones. So always ask that question, how fast is it growing and when do I need to buy more space, right? As a storage admin, very common thing that kind of have to know to do your job right. And so we give all the way back to the past year, natively on the cluster. We can give you the graphs to show, hey, over the last 30 days, I actually decreased 3 terabytes. So there was some of that going on. See, they had a bunch of snapshots going on here, and then looks like they removed some snapshots. You can kind of see where your trend lines are going, and you can kick that back to the last year. And then as you keep scrolling down, you can see, all right, right here, someone deleted 3 terabytes. Okay, is that supposed to happen? Click on it, scroll down a little further, we show you exactly where that data was deleted from. So if all of a sudden you had a big change in capacity, you know exactly where to go look or where it happened. Some other cool analytics, we have a full file explorer within, so you can kind of see where all the space is getting chewed up. This kind of breaks down the information and security information. You can click through, get a view of, you know, all of that. The one I like to highlight is, for example, I've got some home directories on here. You can see which users are using the most capacity. You can kind of come in here and click on, all right, what's Mark doing? Why is he using all this space? Why does Mark have a VM data store in his home directory? That is against policy. So you can kind of start to see, you know, 470 gigabytes of VMs that this person has in their home directory. Go have a conversation with them. Some other nice ones we have here. So we break down by both IOPS and throughput, kind of the hotspots and the client workloads. So you can see which directories you're kind of map this out, which ones are, you know, where's all the performance coming from? This is in real time, or you can turn it off if you want to look at it. So right now there's some engineering jobs going on. Break down client metrics. So you can see here which clients we resolved their host names are generating the most load right now. So if someone was being a bully on the system, you could expose that and then see exactly what they were writing to. So all of this is really to make it easy to manage a highly scalable unified namespace. Any questions?
Hey, Shawn, quick question. When it comes to, I know in the earlier slides you mentioned the transformation. Where does that occur?
Are you talking like transforming data to S3?
I guess when I think of transformation, I think about like either like metadata tagging or adding, you know, either renaming the files or doing whatnot with the raw data, right? Is that not what's happening here? Is more just moving data from one point to the other?
Right. So yeah, we're just building a large, highly scalable file system, and then you would share it out NFS SMB to the clients, and so yeah, that would be client-based activity.
Okay, but so you guys don't have something built in where you do the actual transformation of the data, like ETL?
No, we don't. So we do the one we do is this feature called shift or copy to S3. So what we can do is actually, this is primarily used to use a lot of the services in AWS. The data has to live in S3. There's also some cool use cases of doing data sharing between different organizations and using S3 as that kind of go-between. And so we can transform from file to S3 and preserve security and ACLs and that information. But yeah, so we're a NAS platform. We're a scale-out NAS platform. And so ETL, how the interaction and the changing of the data would be client-side activity.
Gotcha. Okay.
Yep. But yeah, so we support NFS and SMB. We do support SMB3, and then replication, snapshotting, all of that is normal. Tying to AD, full role-based access control, as I mentioned, so you can tie this to AD users or AD groups, give people access. Software upgrade, really easy. Come in here under support, software upgrade, drop in the file. We non-destructively automate the upgrade of the nodes across the cluster. So this is really easy. Under the covers, our software is built into containers. We scale out containers across the nodes. So it's really simple for us to do non-destructive upgrades of containers across the cluster. And then all the API integration is really nice. So we have a Python SDK. We do have a CLI tool for those that, like myself, old Linux guy, fully available there. But the API is used for a lot of automation and workloads. So everything I'm doing here in the UI is API based. And then within the API, we have our full Swagger-like documentation. So anything, all the analytics, all the audit log, all of this. So all these analytics that I showed you here can all be pulled with our API, pull it into Nagios or Splunk or whatever other tool that you might have. So that's fully available here.
Hey, Shawn, can you show me, do you mind showing me the nodes again? How's the, not to get into total weeds of the architecture, but does it require 10 gig, 25 gig, 100 gig networking? Does it require data links between the nodes, a separate segregated network? Just quickly discuss that.
Yeah, absolutely.
Yeah.
So yeah, we're Ethernet based, and depending on the node type, we will have anywhere from 10, 25, 50 to 100 gig support. So like the high end all flash nodes are generally going to have 100 gig support. You're going to want to do 25, 50, 100 of that. But some of our low end and like our archive nodes, 10 gig is perfectly fine. So we have either 2 or 4 redundant 10 all the way up to 100 gig ports on a node. And the nodes do communicate with each other across Ethernet. And so that drives to part of like on our all flash nodes for kind of inter-node communication, the 100 gig is very valuable there. And so those can either, depending on the node, so our low end nodes, we don't need to isolate and segregate front end versus back end. But on some of our higher end nodes, we do. And so we'll either, we have the ability of breaking that, using some ports for that, for interconnect, throwing that into a VLAN, what have you. So yeah, does that answer your question?
So do you have the segregation between kind of like the storage network between the nodes and then the client network, right? The front end network.
Yep, absolutely. Yep. Yeah, and so you can do that either at the switch. So we have multiple ports, so you could do hardware by putting them in different switches, or VLANs too. We support that.
Got it. And then do you guys support LACP?
We do. Yep.
Okay.
Yep. Trunking those ports together and all that. Yeah.
Yep.
So apologize if I missed this, but what's the resiliency settings you guys use for the data? Is it minimum 2 copies? Can you configure that? How's that set up?
Yeah, so we do erasure coding, and by default, what we do, so we break it into segments, what we, by default, it's 6 segments and 4 of those primary. So it's called a 6-4. So what that allows us to do is lose either 2 drives or a node. So our default data protection here is 2 drives or a node we can lose based on our erasure coding scheme, but we can increase that.
Gotcha.
So in a 10 node cluster, I would probably increase that. I can also tweak with that. So I have a utility where I can kind of figure out what erasure coding scheme I want to use, because I can tweak it for capacity versus resiliency, right? And so there's some configuration there, but by default to a 10 node cluster, or I would probably start with 3. But yeah, I can increase that. All right, I just chewed up the whole hour.
Yeah, we're top of the hour, and it got real quiet just as time ran out. So thanks, Shawn. That was all really good. Any other questions before we wrap up for the day, guys?
Just quick go back. You mentioned the starting minimum is 4 node cluster is your starting point.
That's correct. Yeah, we start with 4, and that'll kind of get you going. If we go back here, so the smallest node would be a 36. So it would be 4 by 36, which it would get you in kind of a 100 terabyte range. And then, you can, today we support up to what we've qualified as 100 nodes, but we're about to increase that to 150 to 200 this year.
Nice.
And I assume on the networking, the stuff right there for the AMD, that's 2 by 100 gig. Is that 2 cards with 4 ports total, or is that just 2 ports at 100? Is that just single card?
2 dual port cards.
2 dual port cards.
On the NVMe nodes, yeah. In fact, that's the configuration that Sue was talking about, the customer we're just closing up with. It's a high performance for an HPC cluster, and it's I think we got 6 of those nodes. So 2 of the 100 gig links are for east-west traffic, right? The back end stuff,
right.
Get it off in 2 of the 100 gigs. And you always want 2 for each network, right? For resiliency. But yeah, that's how that works.
Awesome.
But
so QSFPs, I assume, right? It's the
yes,
100 gig QSFP.
Yeah, I think those are Mellanox NICs that are in there.
Yeah, CX5s. Okay. Cool.
Yeah, it's the same stuff that you're seeing, right?
Yeah. All right. I just triple validating. Yeah.
Yeah, nothing proprietary there, which is kind of the beauty of it, right? If you're already in HPE's server shop, all the hardware components are stuff that you're used to seeing. Yeah, we were pretty excited when those DL325 nodes came out here this last year. There's a lot of performance you can put in a pretty small footprint there, right? Because they're just little 1U.
Oh yeah, yeah. The dollar to performance ratio too for the CPU compared to what's available right now for the Intel line is also big selling point, I think, for a lot of customers. Not just for storage nodes, but just compute in general.
Yep, all the way down. Yeah, exactly.
All right, well, Boeing team, thank you for your time. Shawn, thank you so much for doing the presentation. Hopefully this was helpful. Next time, Jonathan and I will give you guys a heads up on the topic and make sure it's good for you. I realized this time we just kind of sprung it on you, and that probably was not fair, but it was just a crazy week. So if there's something you want us to do, let me know. I know that we had recently done a tape update too for some other folks, but I don't think that would interest you guys that much at all. So yeah, think of topics that you want, and otherwise we'll come up with one and run it by you before we do it.